Let's try a slightly harder example. Here we have the equation x squared y cubed plus e to the y equals 11, which defines y as an implicit function of x. And again, we want to find dy dx. So remember, we start by finding d dx of both sides. And in fact, let me just split up this one on the left. Taking derivatives is what we call a linear operator, and so it splits up over addition. And maybe for clarity, what I will do is over on the right-hand side here, deal with this first derivative. So we want the derivative of x squared y cubed. And since we're thinking of y as being a function of x, this is really the product of two functions of x squared and y cubed. And remember how the product rule works. When you have some first function, say capital F, and some second function, capital S, the product rule tells you that the derivative is f prime times s plus f times s prime. Well, since f is just x squared, that's kind of the easy part of all of this. F prime is just the derivative of x squared, so 2x. And I keep the second function, y cubed. Then I keep f, which is x squared, and take the derivative of the second function. The second function is y cubed, and since I'm taking the x derivative, remember that's a chain rule problem. So it's not just 3y squared, but in fact it's 3y squared times dy dx. So all of this goes in place of this first term here. So let's just go ahead and write that over here. 2xy cubed, and I'll just bring that 3 up front. So 3x squared y squared dy dx. Next, we have the derivative of e to the y with respect to x. And again, that's a chain rule problem. The derivative of e to the x is e to the x, but the derivative of e to the y is e to the y times dy dx. Just remember, every time you're taking the derivative of a function that has a y in it instead of an x, you'll have an extra term of dy dx. And the derivative of 11 is 0. Well, I have two terms that have dy dx in it, so we'll just subtract this term from both sides. So we'll have 3x squared y squared dy dx plus e to the y dy dx is equal to negative 2xy cubed. And then you want to factor dy dx out of the left-hand side. So the coefficient is 3x squared y squared plus e to the y. And so that gives us a final answer that dy dx is negative 2xy cubed divided by 3x squared y squared plus e to the y.